Welcome back to our segment. We're still looking at reactions that take place in aqueous solution, but now we want to, try and apply these solubility rules in terms of, testing for, some of the very important substances. It could be your halides, it could be your sulfate, it could be your carbon. But bear in mind that our understanding of the solubility rules are very important, in this case, right? So we'll look at, the precipitation reactions, okay, as far as solubility is concerned, and also it has a lot to do with some of the, gas-forming reactions that we would want to also try and focus our attention on, right? So now, if we are testing for the presence of an anion in a solution, right, what is it that we mean when we talk about an anion? These are negative ions, okay? These are negative ions. So if an ion is negative, we would refer to it as an anion, right? For argument's sake, we can talk about a carbonate, okay, as an anion, okay? We can talk about a sulfate as an ion, okay? So these are typical examples. So precipitation reaction, okay, gives us a way to kind of understand or identify, which ions are present in an aqueous solution, right? Okay, and then using the precipitation reaction to identify anions, let's say we are testing for halides as an example, and the halides in this case could be your chloride ion. It is still an anion because it's negative, okay? It is a negative charge. It could be a bromide. Also, it may be an iodide, all right? These are halides which are group 7, right? So suppose we've got a sample of an unknown solution, and what is of interest to us is to understand which ions of the halide are present. Could it be the chloride? Could it be the bromide or the iodide? So what do? We add silver nitrate. Silver nitrate is AgNO3, right? So this is an aqueous solution of silver nitrate. We add it to this unknown sample. Then if there is a precipitate formed, then we can go on and decide based on the color. But if there is no precipitate formed, then what happens? What are we saying? If there is no precipitate, if adding to this unknown solution, so if we have got this unknown solution, whatever, let's say it's X, and then we add silver nitrate. we add silver nitrate, and then we know that there is no precipitate, okay? Then we know that there is no carbonate or no halide in that particular sample of the unknown solution. But what about if there is a precipitate, okay? And if we add nitric acid to this precipitate, what happens? We know that there's either a carbonate or a sulfate, right? Okay, because that's what it means. So if we add nitric acid and the precipitate remains, two things may happen if we add nitric acid. Nitric acid, HNO3, it's a strong acid, right? Okay, so if we add it, it's either a precipitate will not dissolve or a precipitate will dissolve. If the precipitate dissolve, then it means what is present is actually a carbonate, right? All right, this is what we mean. So the unknown sample, we add silver nitrate, no precipitate, we know that there is no carbonate, there is no halide. And then if a precipitate forms and we add nitric acid to it, we know that if the precipitate remains, it's something else. But if we're adding nitric acid to it, it actually dissolves this precipitate, then we can say, yes, indeed, it is a carbonate that is present, right? Okay, and then if the precipitate remains, because its halides are insoluble, then we know it's one of the halides that are present. So this flow chart kind of helps us to understand the bigger picture in as far as testing for these anions. So anions could be carbonate, sulfates, it could be the halides, right? These are of interest to us. Now, testing for the presence of a halide, ions in a solution that is given. Obviously, this solution is unknown in terms of its composition. So the color of these silver halides are very important. Now, if the silver halide is formed, the color will be white. So the silver halide concerned there it's a chloride. Then it's going to be Ag, Cl. So this is a precipitate, right? Then which is solid. And remember, to represent a precipitate in a reaction, we'll draw that symbol to show that it's a solid substance that is actually insoluble, right? But then if it's cream, it's obviously silver bromide. So then silver bromide is AgBr. It's another solid, and then a precipitate that is formed. What about if it's an iodide, right? The iodide, which is yellow in color, would have AgI, which is a solid precipitate as well, right? Okay, now if we want to test for the presence of sulfate ions, okay, which is another anion, what do? We add barium nitrate. So for test for sulfate, it's barium nitrate that is used, solution that is used, right? Take note of the chemical formula of barium nitrate, because if we are going to write a balanced equation of reaction, that becomes very, very important. So if the precipitate forms and then we add nitric acid, the precipitate dissolves, it is a carbonate ion because the carbonate is soluble. So barium carbonate dissolves completely in nitric acid, while the sulfate does not. So if a white precipitate remains, the sulfate ions are present. What is important in this case is to realize that whenever it's a white precipitate, two things may be possible. It could either be a carbonate or a sulfate. But then to determine whether it's a carbonate or a sulfate, if we add nitric acid solution to this, precipitate and it dissolves, then it gives us, it already indicates that this is a carbonate. But then if it doesn't dissolve, it means it is a sulfate. So that comparison, that distinction becomes very important, right? Okay. And then here's a simple question just to apply this understanding or this knowledge. We've got 3 beakers labeled A, B, and C. They contain solution of sodium salts, okay? These are salts whose composition is unknown, but we know that the metal present is sodium. They also contain either a halide ion, a sulfate ion, or a carbonate. So it's either a halide, a sulfate, or a carbonate, right? Now, these are the clues. No precipitate remained in beaker A after testing for halide and sulfate ions, okay? So there was no precipitate that was formed. These are some of the clues. Identify which ions are present in each beaker based on the following. If there is no precipitate in the beaker A after testing for halide, it means there are no halides or sulfate ions in beaker A, right? A yellow precipitate formed, okay? Let's take note. Yellow precipitate formed in beaker B after testing for halide ions. We know the one that has got, that color in terms of, the halide, and we used silver nitrate, right? And then a white precipitate formed in beaker C after adding barium nitrate and it remains after adding the acid. So if we can go back, the yellow precipitate in beaker B is such that, if we say silver nitrate, okay, plus the yellow precipitate is a sodium salt, okay, it's sodium bromide, okay, iodide because it's yellow, okay, iodide, sodium iodide, okay, which is an aqueous solution, okay. What was formed here is silver iodide, right, which is a solid, right, plus a sodium nitrate, right? Sodium nitrate, okay? So the precipitate, this is the yellow precipitate that was formed, okay? So the halide that's present in B is actually the iodide one, okay? So we can immediately, so if we were to write down the precipitation reaction ionic, we would have silver ion, okay, in aqueous solution, because these are reactions that take place in aqueous solution, plus the iodide, okay? Which is in solution, it gives us that precipitate, okay, which is that color. Okay, so that's the precipitation reaction that occurs there, right? Then a white precipitate formed in beaker C after adding barium nitrate and remains after adding the acid. So this definitely, if it's not soluble, if it remains, it means what was present there is actually, if we add, because it's a sodium salt, we can immediately predict that it's a sulfate, right? So if it's a sulfate, we have got that, okay? That's the salt, okay? Plus, we added barium nitrate to it, okay? Barium nitrate, okay, aqueous, okay. What did it give us? It gave us barium sulfate, right? BaSO4, okay, solid, okay, which is the precipitate here. That's white in color, okay. Plus, what did we have here? We also have sodium nitrate is the other substance, all right? But also take note of the chemical formulae, right? So if we add nitric acid to this and it doesn't dissolve, then it tells us that it is the sulfate that was actually formed, right? Okay, so in as far as, but the reactions, we need to understand how we test for each of those anions, which is very, very important. But also bear in mind that if this was a carbonate, what would have happened? One may ask. Let's say if it was a carbonate, then we know that if we added the acid, and the acid that we're talking about here is nitric acid, right? It's nitric acid, which is a strong acid, right? So if we say, so for argument's sake, it was barium carbonate, okay? Okay, it was barium carbonate, okay. And then plus this is precipitate plus HNO3, all right, aqueous. This is actually a gas forming reaction, right? It will give us a salt and carbon dioxide and water. So the salt that will be formed will be barium nitrate and carbon dioxide, sorry, barium nitrate, right? NO3. To take note of the formula, plus carbon dioxide gas, right? So take note of the symbol there. That's my, and then also water will be the other product that will be formed in this reaction. So this is how we distinguish between a sulfate and a carbonate. So if it was a carbonate, it was going to be a white precipitate which dissolves after adding the acid, which is nitric acid. Okay, so these are some of the tests that you actually do, but of particular interest to us, again, beyond just knowing or, predicting, we also need to be able to write the correct equations for each of those precipitation reactions. And a lot of practice will actually go a long way in us understanding some of these very important concepts. Okay, that's the time we had for today. Just do as much practice as you possibly can on these equations. Otherwise, for myself, Themba Ncube, it's bye for now.